Good afternoon, everybody, and welcome to DBA Fundamentals Down Under. My name is Warwick Rudd, and I'm your host this afternoon. This afternoon's session, we have Understanding SQL Server Backups and Restores by Tim Radney. Now, I'd like to put a big thank you out there to SQL Sentry for supporting us with this session. Before I hand over to Tim, there are a few little call-outs that I also want to make. So for the upcoming SQL Saturday events in Australia and New Zealand, this coming weekend, we've got SQL Saturday South Island. If you haven't registered, there's still time to register and see some great presentations from both local and international speakers. And then in May, we've got the event in Brisbane. Now, we're also running a pre-con that is open on Power BI for that. So if you would like to register for those events, feel free, and it'll be a great day of speakers and sessions from local, interstate, and international speakers. For next month, we've got Ben Miller talking to us about SQL Server Encryption. That session will be updated and made available for registrations very shortly, so I look forward to seeing you again next month for SQL Server Encryption by Ben Miller. So with that, I'll now hand over to Tim to take us through SQL Server Backups and Restores.
All right, thank you very much. Can you see my screen okay?
I can.
All right. So thank you to the past DBA Fundamentals virtual chapter for having me speak. This is Understanding SQL Server Backups and Restores. So I'll go ahead and dive straight in. I am with SQL Skills. We're a small team of Paul Randall, Kimberly Tripp, Glenn Berry, Aaron Stellato, Jonathan Cahias, and myself. We do instructor-led training known as our Immersion Events in the US, the UK, and Australia this year. We do online training with Pluralsight.com. Our consulting side of the business, we do health checks, hardware, and performance tuning upgrades. We also have a remote DBA services where we do monitoring and troubleshooting for instances. Speak at global conferences such as PASS Summit and SQLintersection. But a big takeaway here is becoming a SQL Skills insider. Paul will send out a newsletter every couple of weeks. That includes an insider video with some cool little tidbit, how-to type video. So very cool to get those in your inbox. A little bit more about the immersion events. We have training from everything from accidental DBA, 2 different weeks of performance tuning, an immersion event on high availability and disaster recovery. That one was one of my favorites. Business intelligence, SSIS, data science, I mean, you name it, just check out our website, sqlskills.com/training. So who am I? I'm a consultant, trainer, speaker, author, all those good things. Little vanity slide. I blog at SQL Skills and timradney.com. I'm on Twitter at tradney, data platform MVP. But the takeaway from this slide is I kind of get into electronics. I've been dabbling in aquaponics, but I farm chickens, goats, and tilapia. So I'm one of the numerous SQL farmers out there. I mentioned Pluralsight. If you're not a current subscriber of Pluralsight, if you'll email Paul at sqlskills.com with the subject line user group Pluralsight Code, he'll send you a code that you can use on Pluralsight's website to get a 30-day free trial of all the SQL Skills content, which is over 120 plus hours of SQL Server training. So like I said, no catches, no credit card, just provide the code, your email address to create an account and get 30 days free. So on to the actual session that I'm going to talk about. So I'm going to go over your backup types. We're going to talk about why service level agreements matter. We're going to talk about which backup type is correct for you, how to know that your backups are valid. I'm going to talk about an approach for backing up large databases. Then we're going to switch gears to knowing how to restore your backups. I'm going to discuss about having a restore strategy. I'm going to demo performing point-in-time restores, performing piecemeal restores, and ultimately the overall goal is for you to have a plan, to have a solid restore strategy and have a proven disaster recovery plan. So jumping straight in, backup types. Which is the correct choice for you or your organization? There are several types. I mean, from a full, a partial, differential, file group, file, a log, a copy only. For any organization, some combination of the above is usually warranted to meet their service level agreements. With service level agreements, you have your recovery point objective. So basically, how much data can you afford to lose? And then your recovery time objective of how long can you be down? If you ever ask a business unit either one of those questions, they're going to tell you no data loss, no downtime. You have to be able to be knowledgeable enough to explain how that's almost impossible and to be able to negotiate something realistic. And what I've kind of found to be the industry standard is log backups every 15 minutes, so up to 15 minutes of data loss, and then anywhere from 2 to 4 hours of potential downtime for even the most mission critical systems. It's kind of unrealistic to have multi-terabyte or half terabyte databases without having very complex, expensive systems in places to not have somewhat of a substantial downtime, such as 2 to 4 hours to be able to bring a system up in another data center. I mean, that's a huge event. It could be 30 minutes to an hour before someone calls that and says, okay, fell over to the DR site. All this infrastructure has to be up before you can start restoring a database. So just know what your capabilities are, and then where those things don't mesh, be able to address and state the facts of what you can and can't do. So I talked about very large databases, and approach. So a very large database is subjective. What makes a database very large? I mean, it could be, I typically look at hundreds of gigabytes or more. So if it's a 500 gigabyte database, that's a pretty large database. At that point, I need to start thinking about, can I partition the database? What's the growth potential? Is this thing going to grow from 500 gig to a terabyte or more? As you start getting these very large data sets, your backups and restores start taking much longer. If that 500 gig database has 10 years worth of data in it, most of that data is going to be stale. Could I split that data into multiple file groups? If the data that's not changing, can I put it in a file group that's read-only? With it being in multiple file groups, the older stale data that's accessed less frequently, I can bring online during a DR scenario at a later time. I don't have to restore all 500 gig at the same time. So if I can split the data into multiple file groups using either partition views, a sliding window partition, mainly migrate it into individual file groups, that's a good option, because what this does is allow for a partial restore. You can restore active partitions or file groups more quickly. So a scenario, a client that I used to work with had a database that was a terabyte in size. It stored some financial data, but it was the type of financial data that you could not change. Once it was written, there was no updates. And we had to keep 7 years worth of history. Since the data wasn't changing and it already had a very great key on it with the date time, I could move the data into yearly file groups. Once it was in that yearly file group, I could set it to read only. Once I backed up that file group and knew I could restore it and had already run CheckDB, I knew everything was consistent, I could then just focus on backing up the primary file group, which was the active data. And so now my nightly backup, or the data I was concerned with of being able to restore the quickest, went from being a terabyte down to less than 100 gigabytes, because I would keep the active rolling year in that primary file group. So if we had an event, I could restore just the primary file group to get the active data back online for my consumer, so the external customers. Then during maintenance windows, or as space became available or time became available, I could then start bringing on the yearly file groups in the most critical order, so the newest data first. So, and I'll demonstrate this. It's a lot less complicated, or it's fairly easy to implement. So I'll kind of walk you through it and then demo bringing on individual file groups at a time. You need to know how to restore transaction logs. Usually when I have an audience in front of me, I'll ask the question, how many of you have ever restored a database? Usually every hand goes up. Then I ask, how many have restored a full backup and then applied transaction logs to it? Usually if I had 100 people in the room, all 100 hands would go up the first question, and I would have 4 or 5 hands still raised when I would ask who's applied transaction logs. So you need to know how to step through that process. And then you also need to know how to perform a tail log backup if you can. So what is a tail log backup? A tail log, or the tail end of the log, are all the transactions that have occurred since the last transaction log backup. So in a traditional OLTP system, you always have a tail end of the log. That's the potential data loss. So if you're backing up the log every 15 minutes and the last transaction log backup was 5 minutes ago and you have a catastrophic failure, you have up to 5 minutes of potential data loss. What I'm going to demonstrate for you is if you have access to the log file, your LDF, then you have a very high probability of still backing up the tail end of that log. So you'll see that in a demo in a few minutes. So you have your full, you've been able to take a tail log, so you'll restore your last known good full backup. Then if you're doing differential backups, you'll apply the most recent differential and then restore your transaction logs since the differential, and then restore the tail end or the tail of the log backup that you were just able to take. If you couldn't do the tail log backup, then your most recent full differential if you have it, and then the log since the differential, or log since the last known good full. Stepping through this, doing a demo, you'll see a demo. I'm going to provide all the scripts and the sample databases and everything for you, so you can step through this in your own time. But you need to practice. The time to go through this for the first time is not in production 2 or 3 o'clock in the morning when your organization has had some catastrophic failure. You want to be comfortable with this where it's just second nature. If you're a production DBA and your job is backup and recovery, this should be simple. So have a plan. You have to know how to recover. You need to test that your backups actually restore. I've worked with clients. I've had a company I worked at for a number of years would encounter on occasion where someone would go in and comment out a particular database in our backup routine because there was going to be something going on with that database. And so they didn't want to have a full backup run that would create additional IO or cause pressure on that database. So they would just comment out backing up this critical database. They would forget to go back and remove the section of the code to comment out. So we could go days or weeks or months without a full backup, except that we were testing restoring our backups on a weekly basis. So if a database didn't back up and we didn't catch it in another report that we were using, we would see when we would go and try to restore that database that we didn't have an actual backup. So that's one reason why it's good to test that your backups restore. Another reason is somebody could go in and modify your backup job to backup to disk null. So you're taking an empty backup. It could be that something's wrong with you're writing this your backups to some deduplication device, and something could be messed up there, and you try to restore your backup, and it can't hydrate your backup file. So you have no good backups. So regularly testing is the most secure, solid way to know that you have good backups. You also need to have a disaster recovery plan, meaning something happens in your organization. How do you recover the database? What do you need? Well, first you need a server. When I ask this question, when I have a physical audience, and I always pick on somebody in the room and I point and say, okay, so your primary, your most critical database server failed. What do you do? They say, well, we restore our backups. Great. To where? To another server. Okay, where is it? If you have to go on Dell.com, you got a problem. You need this plan already in place. You need to know where you're going to restore to. So let's say you have another server, you restore to that server. What order and process do you restore? If you just restore your user databases, are the application guys going to be able to connect to you? Well, if firewall rules are in place, yes, they can connect. Can they authenticate? No, unless you've restored the master database. So you need to have your either a process to restore the master, or you need to have your user object scripted out. So your users, your passwords, those things. So I've included a Microsoft knowledge base article for the sp_help_rep login script, where you can script out your users and permissions and be able to just add those to another instance. Because if you have to restore master, you have to be at the same minor revision number. So if you're version 12.0.4100, 2014 Service Pack 1, you got to be on 2014 Service Pack 1 to restore master. What if you've had some cumulative updates? You got to have those cumulative updates to restore master to a secondary. Well, if you only have your ISO, the downloaded media, and you don't have all those cumulative updates saved as well in your DR site, you may not have internet to go out and get it. So a good safety net is to have those objects scripted out, make that part of a nightly job, so you're outputting that data and store it with your backups, and then you're in a much better place where you can add your users without having to restore master. Then you can restore MSDB, get your jobs back. But this is stuff that you need to have planned, you need to have documented, you need to regularly test, and then you need to know your facts. How long is it going to take to restore? If you have that restore validation process in place and you're restoring your database backups at least on a monthly basis, you have the reports. All this data is in MSDB because it records all your backup and restore history. So create you some reports to go and log that information, how long your restores are taking. And then you have another database where you're keeping up with your service level agreements for those databases. So if you have this mission critical system that you have to be able to restore within 2 hours, but over the past 2 or 3 years, the database has grown to such size that you can't restore it within 2 hours, you can't meet that service level agreement. So that's the time that you start escalating to management stating, we need to do something else. We can't just rely on restoring from full and a differential and transaction logs to have this system highly available. We need to start looking at availability groups, log shipping, database mirroring, some of those HADR type technologies so that you have that system more highly available. So know those facts. The last thing you want to do is have a C-level executive ask you, how long is it going to take to bring back our most mission critical, the livelihood of our business database? And you say, you know what, I don't know. We've never done a restore of it. That's a career limiting move. So this is really the whole slide deck. I mean, I have demo and then we talk about a summary. So we'll go ahead and get out of the PowerPoint. And now we're in Management Studio. So what I always like to do for this demonstration is to start with a clean slate. So I'm going to restore a database called backup sample from a known good state. And then we're going to bring the database online. I'm going to clear my backup history just for the purpose of this demo. And it's also a good time to talk about, I mentioned earlier that MSDB contains all your backup and restore your history. If you're running some very common industry script for your backup routine, it's going to take care of your backup history if you enabled that job. Most of your third-party tools that do your backup and your backups and stuff for you that schedules them will clean up backup history. But if you have created your own process and you're not regularly purging your backup history, then MSDB is going to continue to grow. It's very simple to purge this. You run the stored procedure sp_delete_backup history and pass it a date. So this syntax that I'm using, if you did get date minus 30 or 60 or 90, however much backup history you want to maintain, pass that date to the stored procedure. It will delete all history prior to that date. Now I'm deleting everything after or before tomorrow, so I'm clearing MSDB of all backup history. Typically, this is a 30, 60, or 90. Schedule it in a job, and it will help keep MSDB lean and more optimal. So on to the actual backup and restore demo. What I want to show you is the top 10 sales order ID. So our top sales order ID is 75123. So I'm going to go ahead and back up my database and do an initial log backup. And what we're going to do here is just step through adding some transactions. So we're going to add a 75150. We're going to back up the transaction log. We're going to add 75200, back up the log, insert another record, 75250, and then a final log backup. So we added 3 transactions. We backed up the log after each transaction. So what would our restore script look like? So we can see here we added the transactions. How do we restore this? Server dies right now. Do we restore our full that we took and then our last transaction log backup, or do we need the full backup in all 4 transaction logs in the order that the logs were taken? Well, I'm one of those DBAs that I like to script everything. So I have a script that will be made available to you, that if I run this, it's going to generate my restore script for me. And we can see here that we have to restore our full, and then the 4 log backups that we took in the order that we took them. And then lastly, we'll restore the database backup sample with recovery. What I like to recommend to clients and anyone that watches this demo is incorporate a script like this into your backup process, and you can generate your restore script after every backup that you make. So whether it be your fulls, your differentials, or your transaction logs, if every single time either one of those or any of those jobs run, it generates the restore script for that point in time, then if you have a disaster, you can go and just grab that script, and if you can take a tail of the log, then you can add that syntax. But if you can't get the tail log back up, then you just run your script and you have your database back to the most recent backup that was taken. It's kind of a really good practice to get into, and it takes some of the complexity out at 2 o'clock in the morning if you can just take this, copy and paste it, and get your database back online. So what if we're doing differentials? So differentials are very nice to be able to do. So you're not backing up the same data, a full backup, every single night. If you had a 100 gig database and backing up with compression is 20 gigabytes, then over the course of 7 days, you've backed up that same 100 gig or 20 gig backup file 7 times. If you were able to do differentials and you only have a gigabyte of data that changes each day, then your differential on, say you do the full on Sunday, Monday your differential would be a gig. Tuesday would be up to 2 gigabytes, but if that some of that data in that initial gigabyte was just updated or modified, then it would be slightly less than a full gig on that Tuesday. But for simple math, let's say it's a gig every day. So Monday would be a gig, Tuesday would grow to 2, Wednesday 3, 4, and so forth. But it's still considerably less than that full backup. And it's also, think of it like a cumulative log backup. It's all the data that has changed since the last full. So it's really nice to have that if you can, to get into a weekly full, daily differential, and then transaction logs based upon your SLAs. So again, let's start with a known state. So we'll restore our backup sample back to a normal state. We'll go ahead and clear the backup history again. We'll do our initial demo diff full and demo diff log. And now this is similar to the first demo, except this time we're going to insert a transaction 75150. We'll do a log backup. We're doing another transaction, but this time we're going to make a differential. You'll notice the only syntax difference is backup database to disk with differential. So to do a differential is quite simple. A third record with a log, and then our fourth transaction 75500, and a final log backup. So we have full log diff, or diff log log. So what would our restore script look like? Would it be the full and the diff in all the logs, or full diff in each log after the differential? Well, again, I have a very similar script, except this one also looks for differentials if you have them. So we'll take a look, and we see that we have a restore database. We're going to do our full, a differential, and then the last two logs that were taken after the differential, and then finally we bring the database back online with recovery. All right, so now on to the piecemeal restore. So I had mentioned during the slides that if you have a very large database, if you can partition the database, then you can back up individual file groups. So we'll start with a clean slate again, and then we'll bring the database online. What I'm going to show here is this old stale AdventureWorks data. I need to update my modified dates to something more current, but this data goes from 2009, 10, 11 to 2012. And then there's 121,000 rows of data. So I'm going to go ahead and do a full backup, and then I'm going to back up the log to null just because I need to have had a log backup prior. Now we'll take a look at the backup file group sample database. I'm just going to refresh because I don't know the state it was in before the restore. So we'll take a look at our properties. We'll take a look at files, and we see that we just have one file and one log. We take a look at our file groups, and we just have a primary file, or primary file group. So now let's go and partition this database. So to partition it, I'm going to create 3 additional file groups, one for 2009, 10, and 11. And then we're going to create a file for each one of those file groups. We're going to call it backup file group sample 2009.ndf, 2010, and 2011. Did I not? All right, did I not do this in order? Oh, sorry, I didn't run the first script. So we'll create the file groups and then create the files and associate to the file groups. And now let's take a look back at the database, and we'll see the 3 additional files. And notice that the initial size is 1 megabyte. So that's modeled after model. So auto growth by 1 meg. That is not a best practice, but for this demo, it's going to work out very, very nicely. And then we see with the file groups as well, we have the 2009, 10, and 11 with 1 file associated with each. So just in case, now let's partition the data. So this isn't a partitioning session. So all I did was step through the partition wizard, and it created this nice script for me. And just in case I blow something up, I'm going to go ahead and do a full backup, and then I'm going to back up the database and specify each file group individual. And just so that you see we haven't messed with any of the data, we still have 121,000 rows. Now comes the cool part. So we're going to restore this database, but we're going to specify the primary file group. We're going to do from disk, and the special sauce, the syntax that makes all this possible is with partial. So we're going to choose with partial. We're going to bring the database online with recovery, and then I'm going to choose replace because the database already exists. The only time you can use with partial is when you're restoring the primary file group. So you notice the only uniqueness here from a regular backup is we're specifying file group equals primary. Once the primary is done, we can do this again with the individual yearly file group. So let's go ahead and execute just the primary file group. And we see that it processed successfully. If we take a look at the state description from sys data files, we see that backup file group sample and the log are online, but the 3 additional file groups are in a recovery pending state. So what happens if we try to query data that we know that is within the primary file group? We query it with no problems. We got 50,234 rows. But what if we access data that we know is not in the primary file group? What happens? So we're going to do greater than 2009. It says one of the partitions of the index for table DBO cells gives us the partition ID, resides on a file group 2009 that cannot be accessed because it is offline, restoring, or defunct. This may limit the query result. So if we look at results, because we started very low at 2009, it didn't exist, we have no data. So let's bring 2009 online, and then we'll go ahead and take a look at the state description as well. We see that now 2009 is online. So what happens if we, to show, if we put boundaries, so everything greater than January 2nd and before December 31st between 2009, we can get all of that data. So 43,000 records. If we query 2009 and above, it's going to throw an error. Again, same thing, but this time with file group 2010, but it stated before that would limit the query results. So if we look at results, we see that we have all of our 2009 data, but our query broke once it hit 2010. So kind of cool. We know that 2012 and 2009 are available, so if we put boundaries and search just between 2009 and 2012, then we get 94,000 records. So your users at this point, if they're made aware what data is available and their application allows them to put dates between, they should be in good shape and can at least function and work. If your application already has date boundaries where the external consumer, so think about financial. If your online banking application, you're already limited to 30, 60, or 90 days, then if that data reside within the primary file group, they're already okay because their stored procedures are already going to pass, get date minus 30 or 60. It's already going to be taken care of. Your backroom staff that have access to all the data, you'd have to let them know what their date boundaries are while you're bringing those other file groups online. So we'll go ahead and restore 2010 and 11 as well. And we'll see that now our entire database is back online. If we query all data, we see that we have our 121,000 records back. So that's kind of cool. I mean, if you've never seen a piecemeal restore, you've just witnessed it. You see, it's not overly complex. I mean, you have to bring that primary file group online first. There are some rules related to with the read-write file groups and how you can restore with the transaction logs and so forth. So there's a little bit more that you'd have to read up on, but you see, it's not overly complex. You just have to know what your capabilities are. Practice it, know that you're good with it, document the process so others can follow that. But it's a really cool way to be able to get a very large database back online much more quickly. Now for some fun stuff. So here's the script that we created from the first demo, our full backup that we took and the 4 log backups. So what I want to do is go ahead and restore to that state. And now we're going to take a look at our top transaction, which is 75250. I want to insert another transaction. This one has some significance with the name. It's 5 nines. We all strive for that 5 nines of uptime, 99.999%. So we now take a look at our top 2 cells, and we have our 75250 and our 5 nines. The worst type of corruption that you could get would be just a completely dead database. So I'm setting backup sample database offline. I'm going to browse out to my data folder. This is my MDF file for backup sample database, and I'm going to delete it. So we now have no data file. We take a look at my databases. We see backup sample database is offline. We're going to try to bring it back online. We get a nasty error stating that the backup sample MDF file cannot be found. Try reverting to a previous status, and you couldn't start the database. I mean, this is a bad error. So if we tried to do a standard backup, so backup log, backup sample to disk, give it a path, we execute, incorrect syntax, oh, sorry, didn't have the whole thing selected. Execute, backup sample could not be opened due to inaccessible files or insignificant memory or disk space, blah, blah, blah. So when you take a backup, checkpoints, written, I mean, things happen. So the special syntax here is we're going to choose with no truncate, which is similar to a copy only, where it's like a backup that doesn't happen. With no truncate tells it to continue on error. Basically, back up what you can. Don't truncate the log. Just, I mean, it's a nice safety net. So we now have backed up a log successfully. We processed 3 pages. So we're going to run the same restore scripts that we had above. This time we're going to specify or include our tail log backup. And now let's take a look at the top 2 sales order IDs, and we have the 75250 and our 59s. So this is cool, but this was on the same server that backup sample existed. I like to give an example. It's a hypothetical. I'm sure it's happened somewhere, but I'll always deny that it ever happened to me. As DBAs, our databases grow, and we have to ask for additional space. If you have ever had to ask your SAN administrator for additional storage, and they tell you, sure, but we have to provision a new LUN, and then a short while later, you get a call that says, oops, we formatted the wrong LUN, and all your data files are gone. Because you store your MDFs on one disk and your logs on another, your data files, your databases are gone. But you still have access to the transaction log. So that's the case over here. We take a look at our databases. This is another virtual machine. We have no backup sample database, so I'm going to create one. This is what you're about to witness as a hack attach. So we create the backup sample database. We'll refresh. And we see we now have a blank database. I'm going to alter the database and set it offline like we did before. And I'm going to come into my SQL data, my backup sample. I'll go ahead and delete the data file. I will come over to the logs or to my backups. So if you're a wise production DBA, you back up your databases to another location, so they're not on the same physical server as your production database. So this would be our data domain or NetApp or whatever device and network share. But I copied the backup sample transaction log over, so we're going to copy it, and we're going to overwrite the existing LDF file. Now we'll try to bring this database back online. We get the same error. We'll back up the transaction log, using the with no truncate. So we now just attached the transaction log from one database to a completely fictitious blank know-nothing database on another instance, and we backed up the tail end of the log. Now, I like to joke and tell people that this is what you can call an extra week of holiday, a bonus, a promotion, a raise, ransom, I mean, whatever you want to call it. You have the potential, if you can do this, to prevent your organization from having to issue an apology of we lost your data to an apology of sorry for the inconvenience that we were down for that period of time. Reputational loss of losing data is pretty substantial. An oops that we were down due to some computer glitch or power outage or hardware failure is a lot easier for clients to justify and accept than they lost my data. So we backed up the database. Now let's show that since we do have our full backup, our transaction log backups, all stored somewhere else and safe and replicated to another data center, we should be able to execute and bring the entire database back online. So this is a server that has never seen backup sample database. We've restored up to the minute of the failure with the 5 nines. I mean, this is huge. You've witnessed it. You've seen how easy it is to do. You're going to have the code to be able to do this. I mean, I was completely blown away the first time I was able to witness and see performing a hack attach. I mean, this is cool stuff. All right. With SQL Server 2014, encryption was added. You know, it was prior to this, we had to use third-party tools, or we had to back up to disk and then use like 7-zip or something else to then encrypt or zip up and encrypt our databases or the database backups. Now, straight out of the box, you can, with 2014, start encrypting your SQL Server backups. Why is this important? Anyone that can get access to your backup files and has a copy of Developer Edition, which is now free, can restore your database and have access to all your data. So although we put SQL servers behind firewalls and we lock down security and all those things, if you're backing up your databases to a network share that sys engineers or other people have access to, how secure are you really being? So kudos to this being baked into the product. How do we make it work? Well, first you need to create a master key. And then you have to back up your master key. Can't, or your certificate. So before you can start using it, it has to be backed up. So we're going to create the master key, then we're going to create a server certificate, and then we're going to back up our master key and back up our certificate. Now notice with both of these, we're having to back up our master key, we have to back it up to a location, and we have to encrypt it by password. So I'm giving it a complex password. When you back up your certificate, you have to encrypt it with a complex password as well. This is important because in order to restore your database to another instance, you have to have this certificate to decrypt the backup. No certificate to decrypt the backup, no backup. In order to restore the certificate, you have to have this password. So, all right, we have to back up and store our certificates, and we also have to retain this password. So you need to have a key vault, you need to have some place that you can store these passwords that you can gain access to during a critical time, or it needs to be something that your team knows and keeps safeguarded, and you'll see why in just a few more minutes. So we're going to go ahead and back up our master key and back up our server certificate. And now, how do you specify the syntax? Pretty straightforward. We're still backing up our database name to disk. We're going to choose with compression, and then we're going to choose encryption. We're going to, you get to choose your algorithm. We're going to use the AES 256, and then we're going to specify which server certificate to use to encrypt the backup. And just so that you can see, I'm going to back up the backup sample database with compression and encryption, and then just back it up with no compression, so that you can see that still using encryption with compression, we get some pretty decent compression rate. So with no compression, our database was 15 megabytes. With encryption and compression, it's 4.52 megabytes. So there used to be a myth that, if you encrypted your database, then you negate any compression with your backups. Well, we can see here that that's not the case. So on the server that we backed up a database with encryption, how do you restore it? Well, the server already has your certificate, so it's no different than any other backup. Restore database name from disk, and we're going to choose with replace. But what happens if we don't have our certificate? So we're going to drop our SQL Skills Encrypt certificate. And now let's try to restore the same backup. We get an error, cannot find server certificate with thumbprint, and gives us this unique value. So restore database failed, it terminated abnormally. So before, we created a certificate and we called it SQL Skills Encrypt and gave it a description. So let's create the exact same certificate. And now let's attempt to restore. Again, cannot find the certificate with this unique thumbprint that was created when we created the first certificate. So you can create the same certificate with the same name over and over and over again, but it's still going to have that unique thumbprint. So we cannot restore this database unless we have this certificate. So let's drop the certificate, and now let's restore the one that we created. And to restore it, you still have to choose create certificate, but we're going to specify from file, and then we have to decrypt the key with the complex password. So again, no password, no key, no restored backup or restored database. So we've now restored our database, our certificate from file, and we're back to being able to restore our compressed and encrypted backup. So what happens if this server doesn't exist? We have to go to another instance. So let's go back up to our backup recovery 2 instance and take a look. So just for safety measures, I'm going to make sure I have it already had the key created. So we're going to create a master key, and we're going to call it new SQL Skills. We're going to restore our SQL Skills encrypt certificate. So notice we have different named master keys, but we're restoring the same SQL Skills encrypt cert that we used to encrypt the backup. So we restore it from file, and we're able to successfully restore the backup to another instance. So like I've stressed, if you have your certificate that you encrypted your backup with, and you know the password that you encrypted it with, you can restore that to any other instance and then be able to restore your encrypted database. So if you have a mirror, an availability group, things like that, I highly encourage you to either have access to the keys or to have the keys in place on those servers. So what else was new with backup and recovery over the past few revisions of SQL Server? With SQL Server 2012, I believe it was Service Pack 2, Cumulative Update 6 or something like that, URL-based backups was introduced. Meaning we could back up to an Azure blob. I like to joke and say that with URL-based backups, kind of like Henry Ford back in the day, you could order a Model T in any color that you would want, so long as it was black. We could back up to a URL as long as it was, Azure. So what's changed with the syntax? Not much. You back up your database, give it a database name to URL, and specify your Azure blob storage location. Now, I'll always drop this down a number so that it works, because you can't overwrite what's already there. Now, notice I'm having to specify with credential. And so I created a credential called Azure Backup. And so if we take a look at Center Security, Credentials, so Azure Backup. My identity, that's my account within my Azure storage, and then you get your password, which is a key from your Azure portal. Very simple to configure and set up. So let's go ahead and kick this off and see what it looks like to back up to an Azure blob. So I'm choosing with compression to go ahead and gain that ability, since I'm pushing this over the wire. Smaller data going across the wire should be faster. And including StatSQL 1, we'll see that it's pretty quick. I mean, I have a decent connection to the internet, and I'm using the East Azure database or data center. So it took all of 23 seconds. So what about restoring? So restore database from URL, specify your credential. I'm choosing replace. It's really no different than backing up to any URL within your data center or UNC path or to physical disk. Now the restore usually takes a few more seconds than the backup. But this is kind of cool. I mean, if you don't have another data center and you need to be able to get your backups offsite, I mean, this is a very inexpensive way to do that. You could still leverage, instead of backing up to URL, you could still back up to disk, and there's, I think it's called Azure Azure Backup, a utility that command line that you can specify to then move all the files in a folder to Azure. So you can still get your backups offsite to your Azure storage, which is really inexpensive. And then from there, you can restore just like we did from a URL. So some really cool options. I'm loving the technology that we're seeing with Azure and its capabilities and Azure SQL Database. But being able to leverage these hybrid type scenarios where you're getting your backups to the storage, you can have that storage geo-replicated. It's really starting to change what we're seeing out in the field. So we've talked about full backups with logs, full differential, file group, doing a piecemeal, your tail log restore, backing up with encryption, backing up to Azure storage. I mean, this is some cool stuff. So we'll flip back over to the PowerPoint. We've gone through a whole lot of demos. And in summary, I mean, we've talked about knowing your backup types, having the proper backups to meet your customers' service level agreements. I mean, that's key. I mean, there's nothing more important than being able to recover data from some catastrophic event to a user having an oops situation where they ran an update without a where clause. I mean, a number of things could turn your data to mush, and you have to restore from backup. And you need to know what those requirements are. Now, how much data can you afford to lose, and how long can you be down? Knowing how to recover. I mean, we've gone through so many scenarios in these demos. How long are these going to take? The best way to know is to practice performing them. And knowing how to perform point-in-time restores. Having a plan. I mean, the first time you perform a restore should not be in production. You need to know or know that you have a solid backup strategy that meets those requirements. And if they don't, I mean, make it known. And if your organization accepts that risk, my best advice is to have an up-to-date resume. Because if disaster hits and your company can't recover from the outage, your company's not going to recover from the disaster, and you're going to be out looking for a job. So have your resume up to date so you get that advantage from your teammates that you work with, because you're all going to be competing for the same jobs. Have that proven disaster recovery plan in place. Go all the way through it. Just because you can restore your databases to another instance doesn't mean that all the other connective tissue is in place. I mean, if you're importing files through ETL processes, how are you going to get those files? If you're providing files to someone else, how are they going to get those files? I mean, all that stuff needs to be known, documented, and tested. Lastly, the demo scripts that you saw me perform, I've uploaded those, or actually in a few minutes, I'll hit update on my website, and you'll see there'll be a zip file, be listed under the 4/12/2016 past DBA fundamentals link. And there'll be a hyperlink that you can click on, and it will download the zip file that has the sample databases and all the scripts that I stepped through. So with that, I want to say thank you all for attending. If you have any questions, it's coming up close to the time. I don't know if you heard the thunder behind me, but we have storms rolling in. But I am available to answer any questions as long as I have connectivity to the internet.
Well, thank you, Tim. Thank you, everybody, for attending this session. So, Tim, we do have a couple of questions that have come through for you. So the first one is to do with partitioning. So what about if there is an update on an online partition to date that has not been restored yet?
Yeah, so that's where you get into the multiple read-write file groups. And there's some tricks along with those. I think with those, any read-write file groups have to be brought online at the same time, and the transaction logs rolled forward to that point in time for them to be available. There's some tricks with the multiple read-write. I really should dive deeper into that and provide a demo for that particular type situation, but this session was written for like a 60-minute. So I don't know how long it would take me to dive further into that, but specifically if there's more detailed scenario or somebody's in that type of situation and they have questions, just shoot me an email at tim@sqlskills.com, because I have teammates that are much more familiar with partitioning per se, and I can definitely help drive you to the answer to those specifics. But I do recall in my early testing, with multiple read-write, you have to restore the transaction logs for those file groups before you can bring them online, which means you had to restore all read-write in the beginning, which kind of would defeat the purpose. If you partition a terabyte database into multiple file groups, but they're all read-write, it's not going to help you a whole lot. But again, it's been a while since I've played with that, so I would have to dig in again to give specifics.
Okay. So with the slides around the encryption, so the question was, so if you have multiple instances, would you create the same certificate on all instances so you can restore a database to any of the instances?
So you can have multiple certificates. So I probably wouldn't use the same certificate and password on all my instances, because that, if there's different levels of security, different security types, just like in highly secure environments, you have a different SQL account per instance. And then you grant permissions from individual servers that need to talk to each other. So in that case, I would probably have a different certificate per instance. And then as needed, I could restore that certificate, because you can have multiple certificates on that instance. So it really all depends. I mean, how secure do you want to get? How far do you want to go with it? I mean, at the bare minimum, I mean, sure, same certificate per instance, just so that you're keeping non-DBAs from being able to restore. But taking it to that extra level, the paranoid guy in me would have a different certificate per instance, so that it's much more secure. So if somebody compromised one, they didn't compromise all.
Okay. Now this question, I'm hoping we get it right, but so it's a two-part to try and get a little bit more information. So the first part was, can you make up a number, i.e. 10, full backups that are automatically date stamped each night into separate files, then removing the oldest after the 10 has been reached, or without a script or an execution plan? Is it built in, or what is the best practice on how to do this?
Well, okay, so are they wanting to split a full backup into 10 individual files, or they're wanting to?
So I think.
Or are they wanting to keep 10 full backups in retention and then roll the oldest one out?
I think it's, they definitely want to do, so a single full backup with 10 retained.
Okay, so that sounds like they're wanting full backups, but only keeping the last 10, or I mean, keeping the most recent 10. So in those to have unique file names. So there's the XP delete files, or something close to that. I'd have to look up the syntax, but there's a built-in function to delete files, and it's for backup files. So you could call that, pass it the path, and give it the date time to delete everything older than. So if you're only wanting to keep 10 days worth of full backups, then you run that sprock or function, and it will go out and delete your backup files older than that that time. Let me see if I can find the actual syntax. But yeah, I mean, that's built in. You could also use PowerShell. I mean, there's a number of methods for being able to do just that. And then most of your backup processes you have built-in things to handle the retention, whether it be database maintenance plans, Ola Hallegren's backup maintenance process, and any of the other third-party tools.
Okay.
So if that didn't answer the question, just email me at tim@sqlskills.com, and I can pull a little bit more information from you specific, toward the specific, and get you probably get you the syntax that you need to do what you're trying to accomplish.
Okay. So it looks like we've got a late one. So can you please explain the recovery steps in the multiple file group scenario? Can I restore the T-log after the primary file group restore is done?
Yes, so when you restore the primary file group, that's your read-write. If you had any transaction log backups after that, you would have to, or you would need to apply. But once you bring the primary online with those log backups, once that's done, there's no more restoring logs. You could then bring on your read-write file groups after, your read-only file groups after that, which is why the previous question with, if you had multiple read-write, you have to restore those read-writes, apply your transaction log backups, and then bring all that online. So that's where if all the piecemeal restore stuff is documented on MSDN with step-by-step and specifics to handle the multi-read-write file groups. My demo was really to kind of step you through the possibility and the functionality, and that piecemeal restores are possible. I have very few clients that are leveraging it, and then those that are, it's a single primary file group and then read-only after that. So fortunately for me, it's been very simple, but again, I can quickly change that and turn it into multiple read-write and do some transactions into each and step through. If somebody needs to do this in production, I'm more than happy to help you step through it, and we can fire up a WebEx and play with it.
Okay, thanks. You're welcome, everybody. So if there is no more questions to come through, I'd like to take this opportunity to thank Tim for his time in presenting this session in our time zone. And I'd like to thank everybody for coming along and being part of this, this session. And the slides and the recording will be up on the DBA Fundamentals website in a couple of days' time once that's been processed. So feel free to go to the archive section on the DBA Fundamentals website, and you'll be able to rewatch this session to keep up with what has been put forward in this session. Okay, on that, thank you all, and we'll talk to you all next month.